Hello, now we come to a short lesson introducing recommender systems and discussing one interesting feature of them, the so-called long tail, which long tail is seen in many areas of endeavor. So we've already given examples, and here we just summarize the problem. It's the personalized matching of items that include people. That's LinkedIn, which is matching people to people, matching items to people, or perhaps collections of items to collections of people. People's to products is online and offline commerce. People to people is social network, Facebook, LinkedIn, etc. People to jobs or employers are job sites like Career Builder or Monster. People plus their queries to the web, that's information retrieval, which we will discuss later on as a different use case. That's Bing, Google, etc. And the recommender systems help in the match of the users with these items. And their goal is to give good recommendations which sort of ease the information overload. Because if you browse everything you could do, you wouldn't be able to do very much. And it's in some sense like automated sales systems. It's either guidance, advisory, it could be persuasion. There are many things it can be. So if we look at the characteristics of the different solutions, there are many different system designs and paradigms. We'll see user-based collaborative filtering and item-based collaborative filtering. Those are different paradigms exploiting um, nearby users or exploiting nearby items. What you do is based on the availability of exploitable data, the speed with which it takes to do the exploitation, user feedback, which is implicit and explicit. You want to build that in. There's obviously, a lot of progress has been made recently in customizing the interface to internet sites based on what they remember about you. And then every domain has its different characteristics. And you also have to remember that what's important is the goal. Your goal is to be as happy as possible, spend as little money as possible being happy. And however, the goal of the internet site, which may not be owned by which may actually be a portal to other sites, is that the collection of site owners make the most money or do whatever they need, or else in the case of say Netflix, not only does Netflix wants to make money, it wants to do it in a way that preserves the customer. So it's not just money today, it's integrated money over the foreseeable future. So we have to we want to make certain you spend more money at Amazon, or you rent another movie, or I should say, you can actually have a slightly more complicated case where you have a Yahoo portal, say, that portal actually is trying to persuade you to click, which allows you to spend money at a commerce site and benefiting a particular manufacturer of whatever product you you find. So that's pretty complicated. So actually trying to make the decision about whether to make the user happy, the site owner happy, the manufacturer of whatever we're going to eventually click on, that's not trivial. So here we have, if you read this, the business news, you'll see things like click through and conversion. These are what happens. This is a measure of how successful a site is. And so, of course, they're all connected. A happy user is a user that comes back to the site, and that's what the site owner wants to do. So we're not actually ignoring the user. We simply have a slight slant on what we do. And all of this, all these are very complicated problems with lots of aspects, and we have to mix all of the above. And as we'll see, everything is really quite remarkable in that there's no theory here. They're just data. Everything comes from the data. We use previous data to decide what to do. And that's a remarkable feature of these recommender engines. They're all data-based, based on data, I should say. They're not particularly using databases. Here we now have a little bit of a side on the so-called long tail, which came from a famous book by Chris Anderson in 2006. And it discusses the importance of identifying items that the user had no idea existed. And an interesting feature of the online stores is they actually sell more less popular items because it's presumably we can use the technology of these recommender engines to bring these less popular items to people's attention. Here's a page on the left, which comes from Anderson's book, and it has a comparison of Rhapsody, Amazon, and Netflix, and it compares what fraction of sales comes from what you might call traditional things and the long tail. The long tail is in yellow, and you see Amazon is 50% comes from the long tail, Netflix is 20, and Rhapsody is 22%. Here we have a way of looking at the long tail, which we'll see in another picture. We plot a number of plays of a movie or a piece of music against um, in a way that you count how many items there are, how many, say, music items there are which are played this many times, and you'll get a few items which are played an enormous number of times. Those are the songs you will find in your brick and mortar shops, and probably you even might know about. And then out here in the long tail, we just have lots and lots of items which are just not sung or bought or what have you very much. And here's some interesting picture over here about the bricks and mortar retailer. At the top, and the long tail retailer or the internet shop on the bottom. You might, for products, have 20% in this category here, 80% not so common. They're in the some intermediate range. When we go to the long tail retailer, it only has the same ratio here, 2% to 8%, but it has a 90% of those products of what things would not be in your brick and mortar retailer. But if you look at this, you'll find the most of the revenues come from this 20%. 80% of the revenues come from 20% of the products, 20% of the revenues from 80%, and all the profits come from these red things, because that's just that's the nature of that business. In the long tail case, it's sort of different. We have this yellow, which is so uncommon, but they're so, see, they dominate. 90% of the items are in this long tail category, which is just so rarely purchased that then you won't find them in a brick and mortar place. And so here's sort of this symbolic schematic that for the actual revenues, 50% comes from the most common, 25% from the less common but still present in the brick and mortar site, and 25% from the items which are only in the online site. And then there's a similar ratio for profits. So this is an important thing to bear in mind, and in some sense this is a win-win situation. The online site is making money from the long tail, and the users are benefiting from the long tail because they would never have seen the long tail without the online site. We have the same type of thing. We'll see that in many different areas of science. We will see the long tail. We've already actually mentioned that in the discussing big science versus little science. Some areas, say like biology, involve a lot of scientists, not in huge single projects, although there are some huge single projects in biology, like sequencing the genome. But if we compare that with the LHC, that is 3,000 people in one project. So if we again look at search, we then now plot the volume of searches, search against the number of search term variations, and you will find that there's a high volume of very short searches and a small volume of very specific searches, and the very specific searches are often the most fruitful because they narrow down the field much better and they give a result which is more helpful to the user. So now we basically define a recommender system. We have a user, and a user request. I want to buy, I want to search, I want a job, I want to make a friend online, and a set of items, the websites, friends, jobs, books to buy. And then the recommender system is meant to return a list of these items, hopefully ranked by such that the ones near the top of that list are the ones most likely to be interesting to the user. We sometimes use the word relevance there. We want to sort the list by relevance. And that term is actually often used on the internet. You will find that when you have an option for return, say books, you can search by relevance, which is what the site thinks you'll be interested in, search by price, search by date of issue, and so on. This has all got lots of so-called contexts, because it's all done for different in different worlds. So Netflix, which is particularly clear because often the movie and the Netflix system is used by many different individuals, so you'll get a different answer for each individual and a different answer for the household than you would for any one individual. And so when we look at our recommender engines, we're going to look at this context, we're going to look at the information about the users, we're going to look at what other users have done, and we're going to look at the properties of the item. And when I'm doing Netflix, I might want to say I'm only interested in sci-fi, or I'm only interested in movies about red balloons. And then we use technologies, which are collaborative filtering and related machine learning technology, which combine all these criteria into an amazing it's still called machine learning, a total system. Netflix's system has hundreds. I mean, the winner of the Netflix competition had over 100 different components in his recommendation system. And so these are pretty sophisticated and complicated, and they're all actually sort of ad hoc because there is no theory here, but they're actually pretty, not, as we'll see when we look at the testing in this field, they're not so, they're pretty scientific, and that it's very easy in some sense to decide whether they're any good. You just change your recommender system to a new recommender system and see whether your criteria of success are changed positively or negatively. So now we move on to a discussion of this Kaggle site, which has competitions, which competition included a very famous one set up by Netflix. Thank you very much. Let's move on to the next lesson.